The average IQ is 100 with a 15-point standard deviation. Stephanie claims to be in the 90th percentile. Use the Z-table to approximate Stephanie's IQ. Round to the nearest whole IQ point. Okay, so when you're dealing with percentiles in the standard deviation, or in the standard normal distribution, you know that a Z-score of 0 is in the middle, right? And that means that there's 50% on each side because it's split exactly in half. So the 90th percentile, 90 is bigger than 50, so it's going to be over here. Stephanie is saying that area to the left of her Z-score and her IQ is 0.9, right? Because 90th percent, 90% is 0.9. So you're going to look in your table and you're going to try to find 0.9 in the table, because this leads you to a Z-score. So when I look at 0.9 in the table, I find approximately a Z-score of 1.3. Now we know the Z-score has to be positive because the percentile is bigger than 0.5. Okay, so Stephanie has a Z-score of 1.3. If she has a Z-score of 1.3, we can work backwards to find her value, which would be the IQ point. So remember, Z-score is value minus the mean over the standard deviation. So her value, or her Z-score is 1.3. I'm trying to find her value, knowing that the mean is 100 and the standard deviation is 15. So the equal sign splits the equation directly into two, and we need to get x by itself. So first thing, instead of dividing by 15, I'm going to multiply both sides by 15. That will cause these 15s to cancel out, leaving me with just x minus 100. And 15 times 1.3 gives me 19.5. So one more step, instead of subtracting 100, I'm going to add 100, because subtraction and addition are opposites. Negative 100 plus 100 leaves me with 0, so I'm just left with x, and we are left with 119.5. Now, the directions do say round to the nearest whole IQ point, so we would say that Stephanie's IQ is approximately 120 based on our data.